I'd like to introduce Robert Collins. He's an engineer who works for HP.
I believe so.
Yep, and you've worked on a whole bunch of different projects, so that's very interesting. Interesting to me. But of course, today we're here to hear about his work on Openstack. Can I just ask you quickly? Do you have any hobbies?
Yes.
Good. What's one hobby? Just very quickly.
Skiing.
Skiing. Well, you're from New Zealand, so that makes perfect sense. Anyway, without further ado, Robert. Thank you.
Mike.
Yes.
Thanks. I'm very happy to be here, and thanks to HP for sending me here to share some of our work with you, and hopefully find out whether it's relevant and so on. So this is going to be a story about ops and a bit about reliability and simplicity in deployment. I'm happy to take questions as we go. I'd rather, clarify things immediately, but I reserve the right to say we'll tackle that at the end or even after the session. Can I just ask everyone here to raise your hand if you're a human? All right, everyone's hand should go up at this point. Can you put it down if you only do development? So you're a developer and not an ops at all, right? So most people here have some ops, about half maybe. All right, if you manage more than one machine, keep your hand up, otherwise put it down. You manage more than 5, keep it up. More than 50, more than 100, more than 1,000. Right, so you should be giving this talk. At HP, I'm involved in a team that's writing tooling for the team that actually runs the public cloud. So I know a bit about our public cloud, but I can't answer any sensitive questions because I don't know the answers. This makes it very easy for me. But we've got some challenges, and I want to kind of set the scene. If you look at a small environment, this is, the typical, I'm just getting started, or it's a small business. There's no high availability. DNS and DHCP, well, they might be on the switch or the router. Probably installed it by hand, maybe from a CD-ROM. Maybe it came pre-installed. If you've got a wise sysadmin, it will have configuration management on it. Probably doesn't have any virtualization. There's just not enough load, not enough demand. You step up a bit, you're starting to get into a medium-sized environment. Maybe HA starts to matter, the business starts to depend in a more economically sensitive way on having everything running. You might be running your own DHCP and your own DNS at this point. They're probably all still manually installed, manually upgraded, and if you don't have CM at this point, you're a lost cause. And you might have some virtualization. So if you have 5 machines, you might have 3 of them running a virtualized stack like Openstack, and 2 of them as manual management, and those are the things we turned on first. And then you start to get really up to scale. And here HA is a must. You're going to have your own DHCP and your own DNS. There's no other way around it. You probably are still manually bootstrapping it. You're probably still installing a machine, or 2, or 5. Automated upgrades, maybe. Hopefully. You will have configuration management. You'll have lots of virtualization. In an environment like this, it's almost certain. And there's a bunch of tools that aim to scale from I've got some HA, some virtualization, to I've got lots of it. Things like Orchestra, Cobbler, Razor, Maz, Spacewalk, Baracus. The list goes on. And what you generally get for all but the smallest setups can actually be abstracted down to a very simple list. You've got some bare metal. You've got some configuration management running in an operating system on top of that. You've got some virtual instances that depend on that bare metal. And you've got some configuration management running on top of that. So I think what I'm going to talk about is going to be relevant to everyone who is running a network with more than about 5 servers. If it's less than 5 servers, I'm glad you're here. I hope you enjoy the talk, but I'm sorry it's not for you. And that's really an expectation thing, because I don't want someone to come away from this going, you know, that was interesting but not relevant. Puppet, Salt, Chef. Some people do configuration management by deploying custom packages that apply their configuration on a large scale. Etc. Keeper is a great auditing tool. It's not, in my experience, a great tool for getting a per machine customized configuration on 5,000 machines. So I'd like to split this in two and say that there's qualitative difference between these two layers. You've got a virtual layer, which is relatively easy to work with. If you need another test machine, you just overcommit slightly somewhere. If you're already at capacity. If you're not at capacity, you just, you know, turn on another instance. Easy to work with. Mistakes are relatively easy to recover from. You can do testing and automation with Flare. And you're generally getting those virtual instances through a cloud layer, Openstack or some of the competitors. But actually, small environments often have something like VMware. VMware does go to big environments. I'm not meaning to diss it. I'm just saying that small environments often don't have a mature cloud environment available. They haven't gone through that overhead, because installing and running OpenStack is not the simplest thing on the planet. In fact, some people would say it's far from. Bare metal isn't quite so easy. You've got some obvious additional concerns. You have to worry about firmware upgrades. You have to worry about physical failures. There's no live migration of a bare metal node. There are some proprietary things that take an actual physical machine and sub-partition it and move it around for you, but you know, that's not what I think of as bare metal. It has a hypervisor layer in it that's just pretending to be an i386 or compatible processor. You have to worry about your network topology. Your actual routers, your broadcast domains, VLANs, network security are things that you can abstract away and pretty much ignore in a virtual space, and you can't in a physical network. Someone may walk into your machine room in a small office and plug in a hostile device or a hostile Wi-Fi access point like we've seen around the conference. And the tools to deploy the virtualization layer are themselves manually installed by their very nature. Orchestra, Cobbler, Razor, Maz, Spacewalk, Baracus, all those tools have, you know, download this deb and install it on a running Ubuntu box. Some of them have download a virtual appliance and DD it onto your hardware. That's incredibly manual. So I think that the CM configuration management on top of your bare metal is not enough, because you can't iterate on your bare metal environment reliably, and you can't iterate on it with velocity because of these hardware-specific problems. Now, in some detail, installation takes a while. Running the bootstrap, downloading everything off the internet onto a new machine, which is what Debian Installer essentially does, you know, you're talking 15, 20, 30 minutes for something that the actual data transfer is 2 or 3 seconds. Even a single hard disk can write at 150 megabytes a second, and a small image can be as small as 200 meg for a minimal server that's just got one very specific purpose. If you manually install your DHCP, it's probably going to be a SPOF. When it fails and it doesn't get noticed because you forgot to put it in Nagios because it's not part of your big infrastructure, and then all of a sudden your VM hypervisor hosts suddenly start disappearing off the network, you'll be swearing about the fact it's a SPOF. And again, by comparison, virtual is relatively easy. To bring up so active-active or active-passive stuff when you've got a cloud orchestration layer is usually just a matter of turning on 2 of the services and letting them do what they do. One interesting thing to think about, though, with a cloud image, one way of provisioning stuff is to take a cloud image from your operating system vendor, such as Ubuntu, deploy that into your cloud. That's a very fast operation. Once you've got the image cached locally, 10, 20 seconds, and then run Puppet or Chef on top of that, configuration management. And that can actually be a dominating factor in terms of deploying a new service. And so when you're reacting to load and you're scaling up, or if you're just dealing with machines that have failed, virtual machines that have failed, a slow installation process matters. And when you're dealing at scale, when you're up at the thousands or tens of thousands of instances or physical nodes, the ability for you to iterate is dependent on your ability to complete a full deploy across the whole fleet. Well, you might work on a small subsection for a bit, but at some point you're going to say, yeah, we want to get that capacity, that capability out to everything. Until it's finished, you can't safely and sensibly start another one going, because at that point you'll be running 3 versions interacting with each other. As an anecdata here, Launchpad, where I worked on for quite a while, had an automated test in the cloud. So they'd spin up an instance, they'd run the test suite. And the test suite took hours to run. When they started doing this, though, it only took, I think, 2 hours, and they were like, we want this to work fast. So they did some optimization. They created a custom cloud image based on the vendor image, and into that they put a copy of their repository and everything needed to run the test suite. So that when they span one up, deploying it was a few minutes, then they just need to pull in only the changes, and then they ran the test for that. So they cut about half an hour off their initial get up and go by doing that. This is actually technique other folk have used elsewhere, obviously. Software upgrades, bare metal, it's pretty slow. Unless you turn F-Sync off, which is a wonderful idea. Yeah, unless you turn F-Sync off, things like depackage are transactional in every single package that goes through. You're going to spend a considerable amount of time waiting for bits to hit disk. And this matters in bare metal because you might suffer a power failure, but it matters in virtual as well, only you normally don't get that exposed. The virtualization layer will often say, well, I'm convinced enough that it will reach the right endpoint, and gives you an answer, yes, F-Sync is completed. Your bits are safe, or safe enough. So I'm still just trying to make the point here that bare metal has additional concerns and considerations, but there are some common answers. You know, for the F-Sync case, run high available. If you're highly available and one machine suffers, it's not such a big deal. One of the places virtualization is much, much easier for software upgrades is you can test it. You can take your existing machine, clone it, run the test, observe that it works correctly, and then apply it to the real machine. If something goes wrong, you don't need to roll back because you'll have found it when you do the test, most of the time. And again, the elastic resources that you get from a virtual cloud are useful there. Repurposing is something that really is unique to bare metal. With a virtual machine and you need to repurpose it, you just kill the instance, you start up a new one. But with bare metal, sometimes you say, we've got too many storage nodes and not enough compute nodes. I want to turn one of those from one role to the other. If you do that with configuration management, Chef or Puppet, I guarantee you will leave detritus behind. You will leave settings that were tuned for one environment and that the defaults made sense for the other, tuned for the first environment, until you notice it, and then you go and put that rule in and you squash that little bit of entropy down. And entropy is hard. I have lost track of the number of times I've seen production failures where it's due to some entropy that was accumulated over a period of years, and when it kicks in, everyone is scratching their head and going, what's going on? We've got to debug from first principles because there's no obvious way this would be happening. And we had Launchpad build Ds go down for esoteric architectures because of changes that were made 3 years ago to a package and not propagated. There was an override setting in Puppet, so nobody knew the default was wrong. Somebody reviewed the Puppet rules and said, hey, there's no need for this to be like this anymore, and so they turned it off. And that bit of entropy that had snuck into the package 3 years ago suddenly kicked in on all the machines and they went dead. So new installs, a fresh, clean start, where you know the way everything is, helps with entropy a lot. And this is my feeling about entropy. I have a very low tolerance for entropy. And it's kind of cute, but you know, entropy leads to failures, failures leads to despair, despair leads to anger. And we get the dark side. So what do I actually want? What am I here to talk about? I want to talk about delivering low latency, reliable, simple deployment and management of your cloud infrastructure on bare metal so that you can run a cloud on top of it and do that with all the APIs that you normally use. So you get a single testing path for deployment. You can test your bare metal changes in the cloud and push to bare metal once you've done it. So how about we start over and start thinking about what we're trying to achieve? Services are what we actually look at. We look at DHCP, we look at DNS, we look at a web service, we look at a database service. Even things like storage are a service. Products like Chef and the Cinder are just services. So looking at what's going on in your network from a machine perspective, configuration management on a machine or installation of a machine is kind of missing the point. It's a step up. And a lot of people have said that before. I know I'm treading on well-trodden ground. When we deploy services and when we validate them, things like Nagios Cucumber are looking at the services. And we want to make sure the service works in production the way we tested it. And they can run on many different operating systems. So a staging environment for a service probably needs to be able to deploy Ubuntu, Red Hat, FreeBSD, and Windows once you're out of the sort of very narrow special case of we can run everything on our single preferred OS. Proprietary products are often a big driver for this, but sometimes it's things like the kernel in a particular OS being much better at timekeeping. So I'm a huge fan of gold machine images. Build an image, test it, validate it, and make sure that it does what you want, and then push it out. But this is where we run into the bare metal thing. Bare metal is quite different from a completely virtual environment. Operating systems, just as a, you know, to tie into that, operating systems are normally shipped as gold images. They don't normally ship as source code. Netflix is running their entire operation on the idea of golden images that they validate and push out, and they do it en masse, thousands and thousands of machines. A large server image with a whole bunch of services in it, if you push a bunch of stuff together, can get over 600 meg, but typical small targeted ones, in my experience, are really larger than 400. And you can push a lot of data around on a 10 gig network, a production backbone. So how, if we take gold images and we say, look, that's how we're going to approach this problem, how's it going to measure up? Speed-wise, you should be able to deploy about 2 machines a second using gold images on 10 gig network. So you can do, you know, 9 minutes to do 1,000 physical machines. That's assuming that you can run your disks and write to them at, you know, regular linear I/O on your disk, and that you've got access to a reasonable backbone. A 10 gig, not a 10 gig backbone in your switch, but 10 gig from your provisioning server, and 10 gig to certainly all of your hypervisor nodes. It's obviously going to be, yep.
Robert, you are eventually already using that 10 gig network for other networks. So are you saying that we should have a 10 gig dedicated GenMe network?
Okay, so the question is, if you've got 10 gig, you're already using it, where does this bandwidth come from? It's not going to just fit on the same wire for free. And the answer is that if you've got a provisioning server that's doing 10 gig, have that dedicated, and then any server you're pushing to is not going to be doing much else at the same time as it's been pushed to. So as long as you've got a backbone in your switch that can do 40 or 50 gig or whatever, because you've got multiple 10 gig ports, you'll be fine. Some of this stuff we still need to validate. Hopefully it's making sense though. If you have a large disk image, like a 2 gig disk image, then it's still less than half an hour to push that out to 1,000 machines over a 10 gig network. without optimization such as having sparse images or maybe using rsync or something else to only transmit and write the altered data. Depends heavily on being able to fit stuff in RAM on your provisioning server. You don't want to be doing disk I/O at both ends. But there's an interesting thing. A lot of enterprise class machines boot very, very fast. They take 10 to 15 minutes. So if I talk about a half an hour to push the data out to a whole 1,000 machines, and you've got a 15-minute boot time on each machine, and maybe you need 2 boots to do it, you can actually be looking at an hour end-to-end from the time the first one has gone through 2 boot cycles and the last one has done the 2 boot cycles at the end of that 15-minute of data transfer window. But an hour to push out to 1,000 machines of bare metal, not virtual, from scratch, a complete image, I don't think that's too bad, and there's a lot of room for optimization. We'll come back to that. And hopefully we'll get to some technical stuff that's interesting soon. Okay, so Devon Ander did a talk in the mini-conf about all the guts of bare metal. Oh, which reminds me, someone asked in that mini-conf, can you boot UEFI over PXE? And the answer is yes, you need a elilo and an elilo conf rather than a PXE Linux config, and we haven't done the integration work to automatically configure that with Nova Bare Metal yet. But I'm sure someone will turn up and say, I've got this machine, only boots over UEFI, please do it. Now your point was kexec. So can we avoid one of these reboots by doing a kexec? I think we can. We haven't done it yet. One of the interesting things is that for a heterogeneous OS, we probably can't kexec, or may not be as reliable. So it possibly needs to be an optional. If you're going from Linux to Linux, then kexec. Otherwise, you know, it might be Windows or something else under there. Just do another reboot. But certainly, yes. At the moment, where we are in this project is we're pulling all the pieces together to make it work. And once it's working, we're then going to be, okay, we've proven it works, let's optimize. Although it's very tempting to optimize now. Oh, so rollback is easy. You take the old image that you had in your glance image store and you push it back out again. There's a caveat. You need to make your services stuff that sits in the image able to roll back. If you have an incompatible one-way upgrade in your new image, you can't. But that's a discipline rather than a framework capability. And one of the really cool things about this, and this is something the OpenStack CI team, we're working with them to enable, is that you can run tests in many more combinations by looking at the machine service level rather than looking at individual source code level. In particular, the upgrade problem where you run Nova version N and Nova version N+1 on the same network at the same time under load is almost trivially tested when you've got machine images of both versions. You just make a single cluster, half, you know, with one version, half with another, and you put it under load, and you see whether the messages that cross nodes work properly. We want to be able, so one of the things I didn't mention is that we'd like to be able to run trunk Nova, trunk Swift at HP. Now, we can't today for a variety of reasons I'm not going to go into. And in future, we may not, but it would be lovely if we could. Because when bug fixes and security fixes come in, there's, you know, a lot of latency that happens when you have to port those between releases, between versions, and that latency isn't good for anyone. One of the key things I want to note about testing is that Nova's got a really deep dependency stack, right? If you have a kernel version bump, just a minor point release, a new build from the upstream, QEMU, libvirt, IP tables, you can completely trash a Nova environment. It's ridiculously easy. And our ops teams have some very strict constraints on what kernel they're willing to run on because of this. So one of the things that you get if you use gold images is you've validated the entire thing. Make your load test demonstrate the problem with a bad version and keep running that every time. And you don't need to worry about, you know, doing an apt pin to that specific build and all the upgrade friction that can cause.
Can't you look at the golden images basically being just a cache of, you know, a set of things that you do to build it and to update it, you still need to reevaluate that.
So the question is, can you just consider the golden image to be a cache of the things that you built your service with, and that when you upgrade it, you reevaluate the cache and maybe upgrade a bunch of stuff? I think to a degree you can, but one of the points you made in your talk yesterday was that caches bring complexity, and how do you invalidate, and
Exactly.
I think that stuff all turns up. So I'd rather think about it as, if you're starting from a clean slate, it's not a cache so much as it's the exact ingredients. Maybe it doesn't matter. So deploying to production, right, okay, so is this ready for use? Can you go out and do it today? If you're very brave. Oh, I think all the bits have been written, but it's not suitable for production yet because details I'm going to get into now. First of all, bare metal Nova. Bare metal Nova is nearly ready for booting one machine in a production network. One. There's been a lot of code, a lot of effort by a lot of people go into it, but there's still more to do before it's really going to be production ready. I believe our intent in Grizzly is to mark it as an experimental feature that people can use, proof of concept, get into it, but we're going to keep iterating the code to make it production ready. Some specific issues. Yep.
Just to clarify a little bit, when you're booting a bare metal machine, are you talking about booting the bare metal machine to run the hypervisor that's Openstack is then running VMs on, or are you talking about booting a bare metal machine to actually do a particular task?
Okay, so what am I talking about booting the bare metal machine for? Everything. So bare metal Nova is about using the Nova API to deliver a disk image to a bare metal machine, and the disk image could contain a Nova libvirt hypervisor configuration, right? Or it could contain a MySQL database that you're going to use for Keystone. It could contain an HA proxy, a Swift node, etc. The reason I say it's not production ready yet, which has probably earned me some death stares from people on the other side of the globe, is that in a production network you've got a lot more complexity than the fairly simple construct it's currently able to do. You need to be able to work with, you want to minimize your data center footprint. One of the constraints it has is that it really wants two network interfaces at the moment. One network interface that has the custom DNS mask that is running and providing a pull that does PXE next host pointers, and then a separate network interface that runs plugged back into Quantum or into Nova Network, which actual production configuration is passed down to, unless you use the file injection stuff, which is Ubuntu specific and crufty and interacts badly with UDEV rules and so on. You can make it work, which is why Dev was shaking his head and saying you're wrong, but it's complexity I wouldn't want to run into in a production environment. Secondly, it does disk file injection. If you want to deploy 1,000 nodes with a half gig image to each, you're going to be deploying a half a terabyte of data, of unique data rather than identical data. So if you want to look at using something like Murder to optimize the process and push the same data to 1,000 nodes, you can't. It's going to be slightly different on every single node. You're going to need more disk space on your provisioning server, and so we're working hard on fixing those issues. You can use it with Quantum now, which we're very happy about, but there's a few weeks worth of work, probably not going to be all landed and bedded down before Grizzly. If it is, we'll hold a party. Heat is coming along really well. It's a very exciting project, and we're looking to use Heat as the orchestration part of this. So when you deploy this image to bare metal, what bare metal machines do you deploy to? How many machines do you deploy to at once? If you consider an HA pair, taking down both sides of the HA pair for MySQL is probably not the best idea. You want to go to one, you want to bring it back up, you want to make sure it's working, get some actual feedback from Nagios that it's okay, and then you want to go to the next one and do the same thing. And you want to coordinate a failover event, which you probably, with only 2 nodes, don't want to do automatically because split brain sucks. So there's orchestration that needs to happen there. And Heat is largely there, and Clint Byram, who's working on Heat with our project, is having some really good success. It's not completely there. In particular, canary-based rolling deploys isn't something that it's got a baked-in answer for at the moment, which is where you say, I'll do one node, I'll wait for it to be okay again, I'll do the next node, I'll wait for it to be okay. And more complex things like maybe you have upgrade your MySQL before you upgrade your Keystone because Keystone's using a new MySQL feature. I don't think anyone's even really started looking at the code needed to drive that sort of deployment complexity. And there's some stuff around the assumption that nodes are just, all nodes are equal and discardable at any point in the cloud, which is a really good design principle to have, but it's not the reality of many of the lower layers of plumbing that we're working with at the moment. So we need to be able to say, hey, this Swift node that's got, however many 100 terabytes of data on it isn't discardable. We don't want to rebuild that just because you decided you were going to scale the group down. It's not such a casual thing. And that's because we're looking at how we implement the cloud itself rather than services that consume the cloud and thus don't directly imply a large amount of resources per node ever. For configuration management, this can be religious is perhaps the best term topic. So we've taken the opinion that we don't need configuration management to do what I'm talking about here. You do need configuration management to run and operate your machines. So Heat will call into your configuration management layer, and Heat delivers the per machine customization metadata as a JSON file, and you then need to translate that to configuration files on disk and restart services. And you should do that as part of whatever CM system you're using. Very small amount of glue. I'll come back to the exact process we use for that. So, that should be all done, right? Anyone spot the holes?
Monitoring.
Well, you build that as a very good point, monitoring. But monitoring, I don't think, is unique in any regard. Like, it's not it's orthogonal. Are there any other holes people can spot? Updates. Yes. I kept saying deploy, 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 but how do you deploy a disk image when you've already got data on the machine? Also, powering on. One of the things I didn't mention, probably a mistake, is that Nova Bare Metal doesn't write boot blocks to the machines it boots. It just boots them over PXE every single time. You've got a highly available infrastructure, right? If an earthquake or something takes out power to your data center, you no longer have a highly reliable infrastructure. There's every chance you'll have to hit a big red button on the wall, turn everything off, and then bring it back up gracefully. So we need to address that. You don't have to address that. You can take that risk if you want. But what we're looking at doing is making the images that need to be able to reboot, be part of a power-on story, create a boot block as part of their early boot process. You may want to do another reboot to be sure that that works, and we probably need to teach Nova Bare Metal to allow them to do that in a graceful fashion. But it's overhead that won't be applicable all of the time. Your horizontally scalable Nova compute nodes that are deployed through Nova Bare Metal don't need to be part of that early set, right? Powering them on isn't going to make any difference to bringing up the cloud infrastructure itself. And so we have written a few tools around this. First one is a thing called Disk Image Builder. This is a thin shim across, Mount, QEMU, MBD, Chroot. It's essentially you end up writing a few lines of shell script to do the installation of your specific service on top of a base OS like Ubuntu or in the near future Fedora, where you've got a wide range of packages available that you can leverage, but you care specifically perhaps about the kernel version and Nova and where you're sourcing that from. We are avoiding encoding policy in this layer. This is just an enabler, and it takes 3 or 4 minutes once you've warmed up your caches to build an image today, and we believe we can optimize that down probably under 60 seconds if we put our minds to it. And I'd like us to get there. It needs to be a fast process, so it can be part of the OpenStack CI gating. I'd like to see upstream OpenStack able to test for cross-version incompatibilities using this, deploying to bare metal and running in a faithful environment. Another interesting question, one of the missed points, is how do you bootstrap one of these environments? what machine do you install first, and how do you install it with Nova Bare Metal? If you're using Nova Bare Metal to install it. So our answer to this at the moment is a very, very simple thing called DevStack. We're suggesting you run DevStack in production, yes. But not for long. So start with DevStack, build an image for it, but load it up in libvirt. Bridge your external network onto it, enroll your hardware into it, and then scale out your cloud. Use Heat, tell Heat, I want, you know, Nova Bare Metal hypervisor, I want 3 MySQL servers, all of the base infrastructure you need. Let it scale up onto it, and then turn off, probably gracefully, the Bootstrap node. Everything is highly available at that point, so you just drop down to degraded mode, and you change your browser to point to the new Horizon or the new API endpoint, and you tell it to scale up again. So you get back to full HA on a subset of the machines in your data center. And at that point, you can choose to either scale the cloud itself directly out over the rest of the machines, or you can run with 2 clouds. So you can have a control cloud that's completely partitioned, but it contains the Nova Bare Metal, you know, hypervisor or system, and that will let you deploy another full standalone cloud with its own copy of MySQL, of HA proxy, API endpoints, etc. on the rest of the machines. And that's kind of an operational question, which way you want to run that.
Just to chime in, Nova doesn't currently support having unified cloud.
There are some technical challenges running a single big cloud, but that's where I want to go. The other variation, though, and this is the one I think is going to be real interesting in the long term, is to take this disk image builder I just mentioned and all the elements that comprise a functional OpenStack cloud and build a single image that contains all of them on one image. We'll need to do some manual configuration of that, which is why we're not doing this yet. But then you have something which isn't DevStack, so it's exactly the same version as you'll deploy elsewhere. So you've got no room for skew. The nice thing about DevStack to Bootstrap is that you don't run the risk of DevStack trunk bugs once you get past the scaling out point. And at that point, it's a new cloud anyway, so if you do have that problem, you don't really care. You can always just start over. Right. So configuration. I mentioned you get a JSON blob. It goes to varlib cloud data cfn init data, and that is all of the unique information that customizes a particular machine. What databases it needs to have available, credentials to log into API endpoints, the works. You need to get that onto all of the machines. So you run Heat. Once you've got it on a machine, what if that changes? Someone scales out the cloud somewhere else, another API endpoint turns up, then they turn off the first one. How do you migrate it around? So when Heat goes, and Heat will automatically trigger an update. It's part of its feature set. It's wonderful. But we need to make sure that we don't disrupt services running on the machine. So we're looking at a 3-stage model. We'll quiesce the services they're running. So stop incoming traffic to them, take them out of HA proxy if it needs that, or just cut them off at the knees if the rest of the network will deal with that gracefully. This also needs the canary thing applied to it, by the way. All right? Because otherwise you could quiesce everything in the entire network when you make a metadata change. Then we'll apply the changes, so taking that JSON and turning it into config files, and then we'll start services back up again. Some services you don't want to kill. You don't want to kill Rabbit at all. You only want to reconfigure it. Other services will take having this stuff changed under them very, very poorly, and even if there's disruption, you'll want to actually stop them. So this isn't a, there is one right way, but there is one right process. Do any shutdown you need to do, apply the change, start everything up again. Now, this is where I think it starts to get fun, because most bare metal ops is going to be looking very similar to what I've been describing, with the exception that you're using Nova itself to deliver it. If you want to do high availability with a DHCPD server that's managed in a cloud environment, you need to make sure you've got no allocation pools. You need to make sure, or you've got database backing it. So how do you self-host this thing entirely? You need to make everything HA. So this is another bit of engineering. We need to figure out how to make the quantum DHCP agent run in multiple places at once and give sensible answers and deal with one of them being down. we need to be able to deal with an API endpoint anywhere in the cloud going down and reconfigure and bring everything back up again. This is something that's not operator specific. I think this is a general OpenStack challenge. We need to do that with the TFTP, with where you get the kernel and RAM just to boot these bare metal machines. And we need to do it with the Swift data that the glance images are stored in and they come down from. I think a minimal dense install to be able to self-host a bare metal environment to drive the provisioning of a whole bunch of clouds is 2 densely populated machines, with each one of them running a full MySQL, Nova, Glance, Swift, Quantum, Keystone, HA proxy stack. Bit of engineering involved to make that work well, and they probably need to be moderately beefy, but 2 machines when you're talking 10 isn't actually a big deal. It's not a low overhead, but it's not terrible either, given that it lets you upgrade easily and get away from the, oh no, I need to reinstall this machine to do the upgrade, which some operating systems require you to do. And it needs to be repeatable. So here's one of the other things. Take a Swift node, throw several hundred terabytes of data, do an upgrade on it. This is what you were asking about before. It's pretty inefficient. You could just let Swift remirror stuff, right? Just wait. Ring's not broken, but the data's gone. Hang on. rsync, 10 gig network. How many terabytes of data do you need before that stops working? So there's this API called Cinder for doing volumes. And I've got this idea that we can take Cinder and teach it about bare metal. So like we've got Nova bare metal, we'll have Cinder bare metal. And Cinder bare metal will allocate unused storage on a node, on a bare metal node, with a Cinder volume ID. In the same way you can say boot this image somewhere in the cloud with this volume, you'll say boot this image somewhere on bare metal with this volume. And on the flip side, if that image is killed or shut down for some reason, Nova bare metal will never deploy to that node unless you tell it to use that volume. So it's captive. Then partition it however you want in your first boot, reuse the data, move var, lib, SSHD keys, etc. to it, and away you go. It's been done for flash-based images of point-of-sale terminals and phones. It's, you know, everyone knows how to do this, but we need to do it and make it repeatable. It's on our to-do list. And once you've got that, you can make the root a completely separate partition. You can make it read-only, no entropy at all. And by the way, at that point, you can also rsync a live running image over the top of everything. Quiesce the services. Don't apply the config just yet. Rsync an entire image on top of yourself. Don't change the kernel, by the way, word to the wise. Apply the config, apply any migrations that were needed, start the services up, and you're now live with your point release, your minor change, whatever it is, nothing lost, and you can do rsync of 500 meg of data very, very, very quickly. I don't have time to show you the JSON input blobs and so on, but you haven't thrown me out of the room yet, so these slides are going to be up on Twitter. You can follow the links yourself after that. And yeah, I think Flickr is a wonderful resource for photos. Do we have any time for questions?
No, we don't really have any time for questions, so.
That was perfect.
Sorry. All right, thank you, Robert. And we have a little gift for you from LCA 2013.